All right, so again, just guessing, but most of your applications will be on the derivative part, and one big one is this tangent line approximation. So here's another question now using a tangent line approximation, and you'll see some differential equations. These are two that I'm pretty sure, and this along with the fundamental theorem are going to be what I would guess, and what I'm going to try and focus on, still giving you a bit of everything here. All right, so let's look at this function. We got a function f. We are told that f of 1 is 4, so they've given us some information right here, so I'm making a note of that. And we have the slope, so that is actually f prime. That's what they have for us here. We want to find the slope of the graph at x equal to 1. So at this point, we're going to figure out what the slope is. So that's just going to be a direct substitution. But we are going to have to figure out what the y value would be there. Okay. We're going to write an equation for the tangent line using the slope and a point. And then we're going to solve the differential equation and get the actual value. So we want to make that substitution for c here. And then once we have the actual equation, we're going to figure out the solution f of 1.2. So we're going to find an approximate value and then the actual value. Okay, so that was just a couple of minutes, and we've planned out what we're going to have to do here. So why don't you stop the video now and again see if you can get this done in that 15-minute range. All right, let's take a look at each one of these parts individually then. So we start off by trying to find the slope of the graph at x equal to 1. So we know the slope equation given to us is 3x squared plus 1 over 2y. So to find the slope here, I need both parts. I need both the x and the y values. Well, I have that right here. There's my x value, there's my y value. So my slope becomes 1 squared plus 1, 2 times 4. So 3 plus 1 is 4. This is 2 times 4, that is 8. I'm going to reduce that. My slope is 1/2. Okay, part B, write the equation for the line tangent to the graph at x equal to 1. So when we're looking for tangent lines, we need the slope. Well, we just figured that out. That was 1/2. And we need a point that it goes through. Well, at x equal to 1, again, we were told f of 1 is equal to 4. So my point is 1 and 4. So I'm going to get my point slope formula. I'm just going to rewrite it again here. X minus x1. And then it's substitution. So I'm going to substitute in my y value, my slope, my x value, and I'll rearrange a little bit, not too hard to move that over and distribute this through. So that is 1/2 x. This becomes minus 1/2 plus 4, so that's plus 3.5. So there's my tangent line. Now I'm going to use that, though, to approximate f of 1.2. So we need to find the approximate value of 1.2. Okay, so let's keep going here. I'm going to find f of 1.2 is actually going to equal, I'm just going to move this over just a little bit here. That is going to equal 1/2 times 1.2 plus 3/2. I'll even put it as 3.5. So 1/2 of 1.2 is 0.6 plus 3.5. Approximate value of f of 1.2 is approximately 4.1. So we found our tangent line, and then we have our approximate value. part C now is solving the differential. We're going to solve this differential equation. Okay, so we're going to set that up, and I'm going to just rewrite again. Well, maybe I won't to save some space. So remember, when we solve a differential, we need all the y's on one side, all the x's on the other side. So this is actually when I move my y over and cross multiply, I get 2y dy, and then I have 3x squared plus 1, and I'm cross multiplying dx. So we're separating out our x's and y's. Next step, let's take the integral of both sides. So the antiderivative of both sides here. Well, these actually work pretty nice because remember, this is a 1. I'm going to add 1, so that's going to be y2, and then I divide by 2. Well, that just cancels out, so I get y squared. Over here, I'm going to add 1, so that's a 3, and divide by the 3, so that is x cubed, and here this is x to the 0, that just becomes x, and this is the point where I put in the plus c. There's my general solution, but we are told in the question again that f of 1 is equal to 4. So let's substitute that in. So we know 4 squared is 1 cubed plus 1 plus c. So let's go ahead and solve for c. 16. This is 1 plus 1, that is 2. So my c is 14. And if we scroll this up just a little bit, now I can get my actual y squared equals x cubed plus x plus 14. Now the question, I've got to bring it back down, but the question said find f of x. Well, right now we have y squared, or f of x squared, so I'm going to just take the square root of both sides, and instead of y I'm putting f of x is then the root of x cubed plus x plus 14. So make sure we take it to that next step and actually have it solved for f of x. Now that we've solved that differential, and I hope that is getting a little easier every time we do that, we're going to use that to find the actual value of f of 1.2. All right, so f of x, we're going to do f of 1.2. That is the square root of 1.2 cubed plus 1.2 plus 14. Well, this now becomes a calculator question. So again, I'm not going to show it, but I'm going to punch this into my calculator. 1.2 cubed plus 1.2 plus 14. That is 16.928, and I'm going to take the square root of that, and I have f of x, f of 1.2 is equal to 4.114. So 4.114, remember our approximate value from before. We're done here, but just the approximate value from before using our tangent line was 4.1. So we were pretty close, and that's what they're going to look for there. Okay, there was yours, and I'm pretty sure that was under our 15 minutes.